Okay. Hello everyone. Today we're going to be solving systems of equations with three variables. So, since we are missing class today due to a hurricane, but I'm going to start off with the same problem I left you guys with last class, so because we weren't able to finish it anyways. So, here it is. Go ahead and copy it down and make sure you're taking good notes. So what you want to do is you want to get rid of one of the variables, whether it's x, y, or z, for two sets of equations. So you get a normal systems of equations that are two equations with two variables like we're used to solving. So what you want to do is you want to identify something that's easy to get rid of. So I'm going to pick z's this time because all the coefficients are 1s and negative 1s. They're probably easy to deal with. So let's go ahead and combine equations 1 and 2, and then equations 2 and 3. There's probably an easier way to do it, but we'll just do this one for now. So we'll just copy the equations and rewrite them. X minus y plus z equals negative 2. Negative x minus y minus z equals negative 2. And now that you see, these two will already cancel out. So we can just add them together and get a third equation. So if we do that, x's are gone, so those are eliminated. We get negative 2y. Z's are gone, equals negative 4. And that kind of just gave us an answer right away, which is really nice. So we get y, if we divide by negative 2, y equals positive 2. So there's an answer already. Knowing that actually gives us an advantage. We'll stick with the same plan. So we'll combine 2 and 3 now. Same thing, just copy them both. So negative x minus y minus z equals negative 2. And 2x plus 2y minus z equals 7. And again, we're trying to get rid of the z's. So from what we did last time with elimination, we want one positive z and one negative z so they cancel out when we add them together. So I'm going to take this first one, I'm going to times it by negative 1. And that will do it, because we'll have negative z and positive z, then we can add them together and cancel them out. So that'll be a positive x plus y plus z equals positive 2. Then we could add those two up. So that's 3x plus 3y. Those are gone, equals 9. And since we know what y is already, now usually we would do another elimination with these two equations. But since we know y, we're just going to plug that in, we're going to get x. So y is 2, so we have 3x plus 3 times 2 equals 9. So that's 3x plus 6 equals 9. Minus 6, that gives us 3x equals 3. And that'll give us x equals 1. So now that we have two of them, x and y, we can go back to the original three equations and get z. So we're going to plug in 1 into x, 2 into y. Doesn't matter which equation you use, we'll pick the first one, that looks easier. So now it's going to be 1 minus 2 plus z equals negative 2. That's negative 1 plus z equals negative 2. Add 1. And we get z equals negative 1. Okay, so question number 2 here. We have 2x plus y minus 3z equals 2. Negative x plus 4y plus z equals negative 10. And 3x minus 2y plus 2z equals 10. And you want to, again, pick whichever one letter is going to be the easiest to eliminate. From what I'm looking at, maybe either Y's or Z's. I don't think there is a best pick there. So let's just do the exact same thing we did before. It doesn't have to be equation 1 and 3, but you can use like 1 and 2 and then 1 and 3, or you can use 1 and 2 and 2 and 3. It doesn't matter which pair that you pick, as long as it's the easiest ones to eliminate. So let's do the same thing. We'll combine 1 and 2 again. So let's see, that's 2x plus y minus 3z equals 2, and negative x plus 4y plus z equals negative 10. So let's go ahead and eliminate the y's this time, just to do something a little bit different. So we're going to times this one. If we're getting rid of the y's, we want positive 4y and negative 4y. So I'm going to times this by negative 4. Don't forget it goes to there too, that's a common mistake. So that gives us negative 4 times 2x is negative 8x, negative 4y, plus 12z equals negative 8. And then the second one we could just copy. Or you can use it to add up and get your answer. Plus 4y. Plus z. Add them up. Negative 8 minus 1 is negative 9x. Those are gone like we wanted them to be. Plus 13z equals negative 18. Might end up with some harder equations to solve because of the awkward numbers here. We'll just have to deal with it. So now we can get, since we're getting rid of y's, we'll get rid of these two. Or you, like I said, you can use 1 and 3 if you want to. We'll just stick with 2 and 3. Negative 10. Pay attention to your signs. 3x minus 2y plus 2z equals 10. To get rid of the y's here, you probably want to times the second one by negative 2, or positive 2. Because then we'll have 4y and negative 4y. So we just go ahead and copy that first one because we're not changing it. And then distribute the 2 to all 4 terms here. So that's plus 6x minus 4y plus 4z equals 20. Add them up. So we got 5x, those are gone like we wanted, plus 5y equals 10. And now we have to use elimination with these two equations. So let's go ahead and copy them up here. Five x plus 5y equals 10. Then you want to look for the best thing to eliminate here. 5 and 9 both go into 45. 13 and 5 both go into 65. So I'd probably get rid of the x's, just because it's a smaller least common multiple. It's kind of like a common denominator. So we have to multiply both equations by something to make that happen. So we'll times this one by 5 and this one by 9. And that's going to let us solve for z. Once we have z, we can plug back into one of the other equations. So this is actually a z here, not a y. Whoops. Z. Z. Sorry. So that gives us negative 45x plus 65z equals negative 90. That was the first equation. Second equation is positive 45x plus 45y equals 90, which is going to give us a nice answer when we add those together. Those cancel out like we wanted. 65 and 45 make 110y, but it equals 0, so y equals 0. And it's actually z, it's not y. I keep writing y. Whoops. It'll make me want to redo the video. Alright, so we had z equals 0. Now we can take that, plug it into the one of the equations that you had two letters for. So if we plug that in here, we have 5x plus 5 times 0 equals 10. So 5x equals 10, which gives us x equals 2. So there's another answer. And then you take that and you plug it into one of the original three to get your y value. So whichever one looks easiest, I'll just take the first equation. So 2x is 2 plus y minus 3 times z is 0 equals 2. That's gone, so that's 4 plus y equals 2, and y equals negative 2. There is our answer there. If you want to write it like a coordinate point, x, y, z, it would be 2, negative 2, 0. Okay, so question number 3 here. We do get a little advantage with this one because there's no z in the second equation. So what you want to do is you want to take out of the three equations here, you want to take 1 and 3 and you want to get rid of the z, because then you'll get equations with x and y maybe, and then it'll be easier to solve. So we're going to add 1 and 3 together this time. So it's x plus 2y minus z equals 4, negative x plus 3y plus z equals 6. Since z's already cancel out, x's cancel out too, which is going to be nice. We can just add the equations together so we don't have to multiply anything because they're already gone. So these are gone, we get 5y. These are gone, equals 10. So quick answer, y equals 2. The easiest equation to plug that into is going to be the second one. So we can get x. So plug that into equation 2. So that's 2x minus y equals 0. 2x minus 2 equals 0. Add 2. 2x equals 2. And if we divide by 2, x equals 1. And then again, pick your easiest equation from 1 and 3 so you can get z. So we'll just take equation 1. X plus 2y minus z equals 4. Plugging in 1 and 2 into x and y, so that's 1 plus 2 times 2 minus z equals 4. This is 1 plus 4, which is 5, minus z equals 4. Subtract 5. So negative z equals negative 1, or z equals 1. So that would be 1, 2, 1. Okay, number 4. So we'd probably use the same method to solve this one, but if you notice, equations 1 and equation 3 are multiples of each other for x, y, and z. So if I times this by 2, I get the exact same thing, which means those lines are parallel because they do not match on this side. So right away you can kind of tell the answer is no solution, because 1 and 3, if we did the math on it, so x minus 4y plus z equals negative 1, 2x minus 8y plus 2z equals 8. Use the same elimination method you would. You're going to times this by -2. Because you'd want to get rid of at least one of the letters, but what's going to happen is they're all going to disappear. Because we get -2x, -2 times -4 is positive 8y, -2 times z is -2z, equals positive 2. So if we add them up, we get 0 plus 0 plus 0 equals 10. So that tells us no solution. You might not have noticed that if you went with combining 1 and 2 and then 2 and 3. You would have gotten 2 equations out of it, but something weird would have happened when you tried to combine them and get another equation out of it. But you always do want to check your answer for these questions, typically. So that is the end of this chapter, Systems of Equations with 3 variables. So let me know if you have any questions in Canvas. Okay, so next we're going to be graphing systems of equations, but inequalities. And we're shading the graphs here. So if you remember from previous sections, if you have an equation with just y or just x in it, then they are either vertical or horizontal. So these are kind of the easier questions to deal with. What I like to do is list the information out. So I'm going to call this equation 1, this equation 2, and I'm just going to list the info so I can graph it. So for 1, we have, let's see, a y equals, so that's a horizontal line. It is less than, and it is also not equal to, so it's dotted at y equals -2. For equation 2, it's a vertical line because it's x equals. It is greater than, and since it is equal to, it is a solid line. So with that information, we can graph it. And I don't shade until the very end. Some of you might, that's okay. So y equals -2 is down here, and it is a dotted line through that. And since it is less than, I just note that with 2 arrows going downwards. So I know I'm shading under that line. The vertical line at x equals 0, that would be here. It's right on the y-axis. So you make a nice dark line through there. That's x equals 0. And we're going to shade greater than that line. So if we're shading greater than this line, we're going to shade this way. And you just shade where both the arrows are. So there's only one arrow here, there's no arrows here, there's one arrow here, so there's both arrows here. We're going to shade down here. Okay. Second equation. Again, I like to do the same thing, list the information for equations 1 and 2. So equation 1 is already solved for, so we can say, okay, our slope is 1/2. So we're going to rise 1, run 2. Our y-intercept is from y equals mx plus b. That's going to be 0, -1. It is less than and not equal to, so it's dotted. Equation 2, we have a little bit to do because we have to solve the equation. So -x plus 2y is greater than 8. We're going to add x to the other side, so we can say 2y is greater than positive x plus 8, and divide each by 2. I'm not going to list the information for this one, we're just going to graph it because I am running out of room. So we got y is greater than 1/2 x plus 4. So make hash marks 1, 2, 3, 4 in all directions. Okay. First line, we start at -1. Go up 1/2, and it's less than. So up 1 over 2, it's a dotted line. And we're shading under that line. Second line, we're going to start at 4. And it is the same slope, so it's going to be parallel to that one, up 1 over 2. Do your best you can to make that happen. Parallel lines. But we're shading above this one. So since the shading doesn't even intersect in either of these, we actually get no solution. We don't shade anywhere on this graph. If the shading is going this way, in for both, then you would shade the middle. But since the shading is going out for both, we actually get no solution. Because the shadings don't intersect for each line. Number 3. Title my equations 1 and 2. So for equation 1, 3x minus 4y is less than or equal to 8. We can minus 3x over, so negative 4y is less than or equal to negative 3x plus 8. Divide each by negative 4. Since we divide by a negative number, this sign flips. It's now greater than or equal to. Negative 3 over negative 4 would be just positive 3 over 4. X. 8 divided by negative 4 is negative 2. So there's the first line we're graphing. 2. 2y minus 3 greater than 4x minus 1. Probably want our constants all over on that side, so we're going to add 3. So we have 2y is greater than 4x plus 2. And y is greater than 2x plus 1. Now we can graph both of these. To do that, I'm going to erase problem number 1. So number 3 here. For this one, we start at negative 2. We go up 3 over 4. Since it is equal to, it's a solid line, and we're going to shade greater than. So we're shading above this line. Remember, greater than or less than, you always go straight up or straight down. You don't need to use test points or anything like that. Second line, we start at 1. We go down 2 over 1. You want to do that until they at least intersect, because you have to have a good intersection to see where you're going to shade. It is a dotted line because it's not equal to. So extend out your lines a little bit to make a nice graph. And for this one, we are shading greater than as well. So we're shading above this line, which puts both our arrows in this section up here. There's only one arrow here, 0 arrows here, 1 arrow here. We're going to shade right here. That whole section.